Everyone, welcome. So, I think it's nicer that we do this rather than just talking at people, that we have a bit of a conversation. I think the idea behind this was that we'd try and give people a flavour of the type of things that we're doing, what's going on in the European Union in terms of funded projects. And one that we're particularly proud of is because it's been gotten through IC4 essentially, and we have some wonderful partners that you'll learn about, is this CloudLightning project, just funded at the start of the year. And I would just want to give you a flavour of what it is and give you an idea of the type of thing that we're doing. I'm not going to go into great technical details. I'm trying to give you, if you like, the elevator pitch so that you'll say, well, what's that all about? But if you want to ask technical questions, then please do. We'd be sort of more on comfortable ground doing that. So what I'll do is I'll just say who we are, give you an overview of the consortium. Then what we postulate as a typical cloud usage, how the cloud is used at the moment. That's not 100% true for everybody, but it's kind of the interesting usage from our perspective. Then I'll tell you what we're trying to do, how we propose to do it. We've done some initial qualitative studies to try to validate what we've done. So I'll just give you an indication of what they are, and then we'll just finish with some of the challenges. But jump in any time if you want to ask a question, or if I say something that you don't understand. Not because you don't understand it, because I'm not clear, obviously. Oh dear. So this is who we are. We're Intel Shannon, Ireland, Dublin City University, Duth in Greece, and then CERT in Greece as well. So we've got two Greek partners. George is from Duth. Then we have Dana from the Institute Austria Timișoara in Romania. We have Maxler Technologies from the UK and the USA. Tobias Becker will be joining us later. He's flying in at the moment and is going to talk a bit about their technologies. We've got the Norwegian University of Science and Technology, and of course UCC. So we have a broad spread of people there across Europe with a huge diversity of specialities in different technologies. Now, so what we postulate, we notice that the cloud is kind of used in this way, right? We have currently we would contend that the customer has to do all the hard work. If you're a customer, you want to use the cloud, you have to research the various offerings that are available, so that you can build and compile your solution accordingly. Now, if it's software as a service, that's probably not that difficult to do. If it's platform as a service, maybe it's a little bit more difficult because, again, you've got to use that platform, you've got to populate it, etc. If it's infrastructure as a service, effectively you're going out there, you're building everything from the infrastructure that the provider is providing to you. So you as the customer, you want to know, does that provider give me the type of hardware that I need to solve my problem? I really need to know how to solve my problem, and then I must go and deploy my solution on the cloud. So you're doing all the hard work, right? Now, in doing that, you'll find that you're kind of targeting the lowest common denominator to facilitate portability between clouds. So you look at different offerings, and you say, well, if I go for this cloud provider, that's a very specialist offering, and then I'll be locked into that cloud provider. So if I don't go for that solution, I back off a little bit so that I can spread my offering across different providers, then I get more portability. Again, what I'm trying to say is the customer is doing a lot of work. The solution often ends up either being completely generic then, in which case you have an opportunity cost. You lose the opportunity of having a very specific solution and getting the most out of the cloud because you're trying to build in portability. Or you're faced with using some specialist features which then tie you to that provider. So you see what I'm trying to say? You go for portability or you go for the special implementation. In that case, you lose portability. Now, in that scenario, the customer is kind of losing. That's what we're thinking. And all the provider has to do is just make sure that they have enough machinery there to provide for those customers. So, and that's called over-provisioning. Okay, so that over provision, lots of machinery, throw machinery at it, and then it'll all work. Providers are wringing their hands. All we've got to do is look after the machinery. Now, so what are we trying to do in that scenario? What we're trying to do is we want to make cloud computing more accessible to the average customer. We don't think that's acceptable. We don't want the customer to have to do all that work. But at the same time, we don't want to penalize the provider. The provider, there are benefits to the provider if the provider has more control over their offering, more control over their machinery, and they don't have customers reaching in and basically using their machinery, in ways that is not very visible to the provider. So, for example, they can't make their machines very efficient because they can't guarantee that the customer is using their machines in an efficient way. Okay? So what you find then in the typical cloud is that your average server is probably less than 20% utilized. Now, in that case, you're burning electricity, right? If the machine was working at 80% utilization, you're using the same amount of electricity, okay? You probably see no degradation in the quality of service, but you're getting a lot more work out of the machine. So the provider wants to move there, and there's a real need for that because the current model is not sustainable. The cloud is now approaching 10% of the world's electricity consumption. And this is a recent figure we saw somewhere, right? So that's huge, and we have to reduce that. It's not sustainable. Now, what we also want to do, we want to try to exploit heterogeneity because we see that there are different types of resources out there needed for different applications, different specialist applications, and getting at that heterogeneity is a very difficult thing to do, especially for the customer. And we want to, in addition, we want to demonstrate our approach using a very challenging application domain. In other words, we're going to look at high-performance computing and seeing how far we can go down the high-performance computing route using cloud. So that's what we're trying to do in a kind of a nutshell in one slide. Now, it's challenging, as you can imagine. Now, to do that, we need to make a very clean break between the customer and the provider. And what's that clean break? What's that interface? For us, that's a service description. It's a service level interface. It gives us, as I said, this clean break between the customer and the provider. The customer is not reaching over that barrier. It's just interfacing with what service can you give me? Functionally, what can you give me? I'm not dictating what kind of machines you have to provide to give me that service. As a customer, I'm only interested in the service. So specify the service. You as the provider, you provide the service, and you manage your machines to do that, to do that provision. So the interface then should not require the customer to specify the resource requirements. And then they don't have to do that research. They don't have to worry about those things. They only specify what they know. They know about service. They know the service that they want, and they specify that. But there's a catch. If we do that, what we're doing is we're putting all the complexity of managing all that services back onto the provider. So previously, the customer was doing all the work. Now we're saying the provider has to do all the work to deliver that service to the customer. And you end up with a huge, complex system when you do that. Now, we can't underestimate just how complicated that actually is, right? Because you can imagine the provider is getting these service descriptions. They want to respond to those service descriptions. They want to say, how can I provide the service? What do I have in the back end? What's available now? What will be available in the future? And you're talking about tens of thousands of machines. You're talking about tens of thousands of service requests coming in, at a very frequent rate. So how do you do that? How do you manage that? And there's only one way we know how to manage that kind of complexity, and that's through self-organization. Okay? Self-organization is the kind of thing you find in nature, right? We're all sort of self-organized. According to Darwin, we all sort of were the sum of these simple components that are put together, and emergent behavior results, etc. Now, and this was sort of worked on way back as Alan Turing sort of recognized this stuff, and if it's good enough for Alan Turing, it's good enough for me anyway. So this is our definition of self-organization, where we have synergetic activities among elements, but no single element acts as a coordinator, and the global pattern of behavior is distributed among these elements. So how do we kind of bring that into the scene? Well, the idea is that we're proposing a self-organizing model that sort of is analogous to responding to a call for funding proposals. You know the way at the moment that funding bodies like Enterprise Ireland or SFI will put out a call and say, we want proposals in the following area. That's almost like a service description. It goes out to the community. Researchers get together and say, we can collaborate here. I can bring my speciality and I can do this bit and you can do that bit. And little coalitions are formed, and little groups are formed, and then they bid for the funding. Okay? So it is something that's done from the bottom up. It's a bottom-up, self-organized activity in which these individual elements propose themselves, they form coalitions, they bid for the service. And we see that happening in the cloud, where the researchers are replaced by these resource elements in the cloud. So think of every resource element, every server, every disk, every database, everything that's in the cloud as having this sort of intelligence that can allow it to do its own local organization, its own local administration, and say, well, I'm this busy, I've got this capacity, there's this request coming in, will I take part? Well, will that be good for me? Will it make me more busy and bring me into the 80% utilization? If so, and can I do it easily? Yeah, then I'll become part of the consortium. I'll join the consortium and I'll bid. But we'll find that we get lots of consortia being actually created in the cloud at the same time based on the same service request. Now, the interesting thing comes when you see that if your cloud is made up of heterogeneous resources, different types of resources, and some of those resources are very specific and specialist and can respond to specific parts of that service request very effectively, then you'll find some consortia being more appropriate than others. Some of them have the specialists. They've got the expert in the area. They've got the dream group to apply for the funding. Others may be more pedestrian, but we'll get there. We'll be slower, but we won't cost as much, okay? And maybe we can do it now. So you have this heterogeneous response coming from the cloud, and what we do at this point is we bottle it a bit. We say, well, okay, the customer then decides what the customer wants at that point, when they're presented with a number of options. Now you could have some filtering on that, but that again is just, those are details. So we have this automatic configuration and assembly of these coalitions, automatic release of resources then when the task or the service is retired. So the cloud responds, when the service is over, the resources go back into the pool and they're ready for the next proposal. So we have this kind of situation where, just as I described, we have the user sending a service request into the gateway. I don't know if is there a pointer in this, Dana? Yeah, into the gateway. This gateway service propagates the service request through these heterogeneous resources. There are coalitions that are formed, creating these service tenders, and then these service tenders are propagated back through the gateway to the customer. The customer will choose one, and then that's automatically deployed and goes into service. That's basically our idea. That's what we want to do. Okay. Now, around that, there are lots of details, and I'm kind of running short in time, but I just pointed those details. So if we visualize our cloud here as being made up of all of these servers, and these are little access points into the cloud. So service requests can come into all of these access points. And as soon as they come into the access points, they arrive at these internal service platforms here. And they, in turn, then will propagate the service descriptions and will decompose them into functional elements that the server and the resources understand. And then that will happen in many places. A number of coalitions will form, a number of tenders will result, and out will come the smorgasbord, the menu for the customer. There's some basic tenets that we adhere to. The components are autonomous, they're aware of the environment, they're goal-driven behavior of individual components. So individual components, you can say, well, what do you want to do as an individual component? Do you want to maximize your utility? Do you want to maximize your energy conservation? Or do you know, those kind of things. And we can build those into the algorithms, into self-organizing algorithms. So they include things like, well, minimizing, as I said, minimizing energy consumption, etc. Then these goals are achieved then in concert through collaboration. So what we did then in a kind of a qualitative, to try and as a proof of concept, we simulated 9 million components, 9 million using Amazon. Cloud is a wonderful thing. And in these 9 million components, we created our model, we deployed it in Amazon. It was basically a numerical simulation using queuing theory and continuous time Markov chains. These are just details. And then what we were trying to do was get a kind of, does this work? Does this thing behave in the way we expect it to behave? So we asked the question, does the bidding mechanism allow the system to effectively respond to external requests? So we really just hammered the system with tens of thousands of requests per bucket. We broke those requests into buckets. We just threw them at the system. And this is the way the system kind of behaved to us. And we found actually in this case that we had 99.9% success in actually forming a coalition to respond to the service. Now that's given the kind of the configuration that we had. Don't forget we have 9 million elements in there, so it was kind of easy enough. But we find that there, you know, we got figures that indicated to us that this was a viable approach. These are not really quantitative figures, it's just qualitative, it's very qualitative. Yeah, this is worth looking at further. So this is the kind of thing we were doing.
When you said that your request failed in the previous slide,
yeah.
It's because you reached some timeout, so there was a deadlock and there were no...
It was because we couldn't form a coalition to serve, to answer the service, because at the time there wasn't the resources available within the system to provide that service.
Some timeout.
Exactly. So there was a timeout. Yeah. Okay. I'll move on from that a bit. So some of the challenges then in that system, you can imagine that is kind of there's a lot of detail behind there, right? What we're interested in doing is looking at creating a system like that, but also in that system have automatic generation of service level agreements, so that within the system, the coalitions themselves and the rules of coalition formation adhere to a service level description, a service level agreement. Okay, so they would only take part in a coalition if they could guarantee that they're going to result in a coalition that could meet the service level agreement. Cloud service description language obviously is going to be a very difficult thing to do, right? And Dana's groups are experts in that area, and she'll talk a little bit about that in a little while. The bidding algorithm, the self-organization algorithm, these things, we have very embryonic algorithms at the moment. Making those more specific and more detailed to derive the kind of goals that we want are the kind of things we're going to do in this project. We're moving from, at the moment the cloud uses monitoring for resource allocation. So the cloud sort of has this centralized monitoring view of the system, and it says, well, what's available, yeah, and based on what's available can make decisions, resource allocation decisions. Now, with self-organization, you lose that overview. However, you can still use monitoring to monitor the health of the system. So you can see how healthy my system is, how utilized my resources are, but not use the monitoring, which is a very centralized and out-of-date information. Once you gather the information from a complex system like that, it's out of date. So you shouldn't be making it to use, or using it to make decisions, but you can use it to make diagnosis of how the system is behaving and whether or not it's healthy. Self-organizing systems could be integrated into the existing structures of existing clouds. So it's a very, it's a model that can be evolved into existing deployments. And as such, we think it may be the way forward. So that for us is where CloudLightning is going. George is going to talk a little bit about the other side of CloudLightning, which is the HPC side of the other side of the story. And so George will be up next. Dana will talk about the service description, and then Tobias, welcome Tobias, will talk a little bit about some of our specialist hardware that we expect to find in our testbed, and that will include things like data flow engines, and we'll talk about that when it's time for it.